Imagine finding a hidden treasure buried deep inside your own attic. That's exactly what happened here.
Why does wine actually get better with age? You have heard it said 1,000 times. Older is finer. Older is smoother. Older is worth more money. Someone opens a dusty bottle at a dinner party, and the whole table goes quiet, like they are about to witness something sacred. But is any of that actually true? Or is it just a story we tell ourselves because time feels valuable? Let's set the rules first. We are not talking about every bottle on every shelf. Most wine, roughly 90% of it, is made to be consumed within a year or two of bottling. It will never improve. It will only fade, flatten, and eventually taste like nothing at all. So the real question is narrower and stranger than the myth suggests. For that small percentage of wine actually built to last, what is physically happening inside a sealed, lightless bottle for 10, 20, or 50 years? And why does it transform aggressive, young liquid into something people will pay thousands of dollars for decades later? Here's what the chemistry actually says would happen. Picture a freshly bottled red wine. It is full of tannins, those bitter, drying compounds pulled from grape skins, seeds, and stems during fermentation. It is full of pigments, sharp acids, and a small amount of oxygen sealed in at the moment of bottling. At this stage, the wine is aggressive, harsh, almost chaotic, chemically speaking. Dr. Andrew Waterhouse, a wine chemist at the University of California, Davis, has spent decades studying exactly what tannins do once they are locked inside glass. And his research reveals something most drinkers never consider. Tannins do not simply sit there quietly waiting to be tasted. They react, continuously, slowly, almost imperceptibly. Individual tannin molecules begin linking together into longer and longer chains, a process chemists call polymerization. In the early years, these chains are still small enough to taste harsh, grippy, and drying on the tongue. But as the years accumulate, the chains grow so large that they eventually clump together and drop out of suspension entirely. That is the dark, gritty sediment you see crusted along the inside of an old wine bottle. The wine is not gaining tannin as it ages. It is quite literally losing it, filtering itself from the inside out, one microscopic collision at a time, for years on end. So the first stage of this transformation is a slow disappearing act. But that alone does not explain the flavor. Not even close. Let's push the scenario further. Inside every sealed bottle, there is a small amount of oxygen trapped at bottling, along with a tiny, controlled trickle that seeps in through the cork over years, molecule by molecule. Denis Dubourdieu, a renowned enology professor in Bordeaux, spent much of his career studying this exact exchange between wine and the outside world. His work helped demonstrate that this microscopic oxygen exposure is not decay in the way people assume. It is a slow-motion chemical negotiation. Oxygen nudges pigment molecules to bond permanently with tannins, softening bitterness, while simultaneously deepening and stabilizing color for decades. Too much oxygen, and the wine crosses a line into vinegar, ruined completely. Too little, sealed under an overly tight closure, and the wine stays closed, tight, and stubbornly youthful forever, never developing at all. The right amount, delivered at the right rate over the right number of years, is the difference between a bottle that ages gracefully and one that simply dies quietly in a dark cellar. Now raise the stakes again, because there is a version of this process that goes catastrophically wrong. Wine scientists studying spoilage, including researchers cataloging the yeast strain Brettanomyces, have shown that under the wrong storage conditions, contamination can hijack this same aging process entirely. Instead of graceful tannin polymerization and gentle oxidative aging, you get barnyard, band-aid, and vinegar characteristics taking over the bottle. This is the hidden danger buried inside the romantic idea of aging wine. Time does not automatically purify a wine. Time amplifies whatever direction the wine is already heading in. A well-built bottle in good conditions becomes extraordinary. A flawed bottle, or one stored somewhere too warm or unstable, becomes undrinkable at exactly the same rate. But assume, for now, that everything is going right, while tannins are quietly vanishing and oxygen is trickling in at just the right pace. Something else entirely is unfolding beneath the surface. Acids and alcohols inside the wine are slowly combining to form new aromatic compounds called esters. This is not fermentation. Fermentation finished years earlier. This is a much quieter reaction. unfolding over a decade or more, producing scents that were never present in the wine to begin with. Dried fruit, leather, tobacco, wet forest floor. Anne Noble, the UC Davis researcher who created the widely used wine aroma wheel, spent years cataloging exactly these transformations, showing that aged wine is not simply young wine with the rough edges worn off. It is chemically, measurably, an almost entirely different substance than what was originally poured into the bottle. So by now, the wine has lost the majority of its tannin, gained structural stability from careful oxygen exposure, and grown entirely new aromatic compounds it never possessed as a young wine. 3 separate transformations, running in parallel, completely invisible from outside the glass. Does that mean every bottle simply keeps improving forever the longer you wait? Not even close. Every one of these reactions runs on a curve, not a straight line climbing endlessly upward. Tannins polymerize until there are effectively none left to soften. Oxygen exposure helps only until it tips into full oxidation, and the fruit character collapses into flatness and dust. New aromas develop only until the wine's remaining acidity can no longer hold the whole structure together, and everything dissolves into something dull, thin, and lifeless. Wine economist Carl Storkman, who has studied vintage pricing extensively across decades of auction data, has shown that most wines actually reach a clear peak of quality, then begin declining, and that peak arrives far sooner than most collectors assume. For the overwhelming majority of genuinely age-worthy reds, that peak sits somewhere between 10 and 25 years after bottling. Not 50 years, not a century. The romantic idea of a wine improving indefinitely, without limit, is simply false for almost every bottle ever produced. Which raises the real twist at the center of this entire question. Why do a small handful of legendary bottles seem to defy that curve entirely, still tasting vibrant and complex decades past, when everything else would have already collapsed? The answer is not mystique, and it is not magic. It is starting material. A wine destined to improve for many decades needs an unusually high concentration of tannin and acid at the very beginning, well above what most wines are built with, so that even after years of steady polymerization and gradual oxygen exchange, there is still enough raw structure left to carry flavor forward. It also requires a near-perfect cork seal and stable, cool, dark storage, because temperature swings accelerate every one of these reactions unevenly, throwing the whole delicate balance out of sync in a matter of months. Famous old bottles are not simply surviving in spite of time passing. They were engineered, at the exact moment of harvest and fermentation, to contain precisely the raw materials that decades of chemistry would need to work with. So here is what would actually happen if you opened that dusty bottle from your basement, expecting magic. If it was built for aging, with the right tannin and acid levels, and stored correctly for its entire life, and opened somewhere near its true peak window, you would taste something genuinely unlike anything a young bottle could ever offer. A wine transformed by decades of quiet chemistry into layered, softened, unexpected complexity. But if it was an ordinary bottle never intended to last, or if it sat somewhere too warm, too bright, or too unstable for even a single summer, you would very likely taste something closer to flat vinegar and disappointment. Age is not an automatic achievement stamped onto a label. It is a gamble with very specific, unforgiving rules. And most bottles quietly lose that gamble long before anyone ever notices. Which brings us back to something surprisingly human, sitting underneath all of this chemistry. We tend to assume that simply enduring, simply surviving a long stretch of time, automatically makes something valuable. We say the same thing about old buildings, old traditions, old ideas passed down for generations. But wine tells a far more honest story than any of those metaphors. What actually matters is not how long something lasted on a shelf or in a cellar. It's what it was built from in the very first place, and whether the right conditions were ever present to let time do its slow, invisible, unglamorous work. Endurance alone proves nothing at all. It's the combination of strong raw material and the right environment that quietly turns time into something extraordinary. So the next time someone tells you a bottle is special, simply because it's old, you'll know the real answer sitting underneath their words. It was never really about the years spent sitting in that cellar. It was about the tannins, the oxygen, the acids, and the chemistry quietly rewriting the wine from the inside, one molecule at a time, long before anyone ever pulled the cork.